Okay, this is Unit 5, Lesson 1, Day 4, homework question number 15. This comes from page 342 in your Course 3 book of the Core Plus Mathematics series. And this one says, shown below are 4 polynomial functions, each written in expanded standard form, and is a product of linear factors. So we get both. We get the standard form and then all of its linear factors for each term, 1, 2, 3, and 4. So A says, in which form is it easier to see the zeros of the function? Well, zeros are simply opposite factors. So the zeros are easy to see in the factored form. So I'm going to answer this one, say, factored form. And the reason I know that is because the zeros are opposite factors. And then in part B, in which form is it easier to see the y-intercept? The y-intercept is that constant at the end. If we let all the x's go to 0, then that constant in the end would be the remaining y-intercept. So that's easiest to see, I think, in the expanded form. The expanded form, and this is the constant at the end, is the y-intercept. Part C. How many zeros do each of the 4 quartic polynomial functions have? Well, they're all 4th degree. All right, so if I look at the first one, and I look at its factored form, that shows me that there are actually unique zeros. There's a 1, 2, 3, and 4. So there are actually 4 zeros for f of x. So I'm going to write f of x has 4 zeros. G of x, the second one, has 1, 2. It will show 3. 1 is repeated. So I'll put 3 zeros with 1 repeated. And then for h of x, if you were to graph h of x, you would only see 2 separate zeros, but 1 is repeated 3 times. So we'll see 2 zeros with 1 repeated 3 times. And then lastly for j of x, this has 4 zeros, but it's repeated. 1 is just repeated the 1 time. So it'll only show up as 1 0 on a graph, and then it says it'll be repeated 4 times. And then part D, this is how does the collection of 4 functions help to explain why any polynomial function of degree n can have at most n distinct zeros? What we see here is that this is a 4th degree polynomial, and so there are 4 possible zeros there, right? And then there's 3, 2, and 1, and these are all showing us that the most we can have is 4 polynomial. So the degree matches the number of zeros. Degree matches the maximum number of zeros. And that ends question number 15 on your homework.